the online tutor. So today I am going to conduct a remainder theorem and factor theorem tutorial number 2. So the first tutorial we have discussed about the theorem and we have discussed about some questions, and also we identify the special identification of the remainder theorem and factor theorem, right? Those stuffs we have already discussed. So today in this tutorial I'm going to discuss another one more identification and a few more questions, right, including some LL paper questions. Okay, so the first question I'm selected as this. Fx is a polynomial function which is divided by x minus a, x minus b, x minus a, x minus b, and show that the remainder is this, right? So I think this is also again under the special identification, x minus a, x minus b, right, divided by, we need the remainder. So fx is divided by x minus a, x minus b, right? The quotient is psi x, and the remainder is, the divisor is a second order. No? The divisor is second order, means surely the remainder is ax plus b, right? So then we can write the theorem. It's like fx equal x minus a, x minus b into psi x plus ax plus b. So this is my remainder theorem. So the objective is find ax plus b, capital A and b. I'm putting x equal a and x equal b. If a will be capital AA plus b, if b will be capital AB plus b. So I'm going to subtract these two. Then FA minus FB equal capital AA minus capital B. So B also cancel. Then capital A will be FA minus FB over A minus B. I'm just taking A minus capital A out. This is my capital A, so we have to find capital B as well. So by equation 1, which is FA AA plus B, capital B equal FA minus capital AA. FA minus capital A FAFB over A minus B, and take a common denominator. So I'm just multiplying AFA BFA minus AFA plus AFB, right, over A minus B. Actually, which terms getting cancelled? AFB, yeah, AFA also cancels. So it's AFB minus BFA over A minus B. So this is my capital B, right? This is our capital A. So the remainder will be, the final remainder AX plus B, capital A means this one, FA minus FB, A minus B, X plus capital B, AFB, BFA over A minus. This is our capital B, right? So that is the question number 1. So this tutorial I have selected. So what you have to understand, so we focus the remainder theorem with special identification. Once you divide by some polynomial function by quadratic equation, so normally remainder is a first order, it's ax plus b, right? So the others are normally simplification, right? Okay, so we can move to another example. The second example, x cube plus bx squared plus cx plus 1 is divided by x squared plus k squared. Then the remainder is 0. which means x squared plus k squared is a factor of fx, and we have to show bc equal 1. Okay, so first of all we have to summarize. This is our fx, this is our fx, which is divided by x squared plus k squared, then the remainder is 0, right? Fx is x cubed plus bx squared plus cx plus 1. Okay, so right, actually you can't use the remainder theorem right now because psi x, this is 0, right? Because whatever you put as a x, right, the psi x not getting 0, the psi x not getting cancel off, therefore there is no x value suitable for cancelling psi this whole part, right? And also we need bc as 1, no? Bc, the product is 1. Then what I am going to do, I'm just using the long division, x squared plus k squared, x cubed bx squared cx plus 1, and here I am putting x cubed plus xk squared is getting cancelled, b minus this is xk squared, then bx squared, these two plus x c minus k squared out plus 1. So we need to cancel bx squared, bk squared, xc minus k squared plus 1 bk squared. Okay, then this is our remainder. We can't simplify it further, and you know this is x squared plus k squared is a factor of fx, right? Factor of fx means this part and this part is should be 0 because there is no remainder. This part getting 0 means ck squared equals 0 or 1 equal bk squared, 1 minus bk squared c. Ck squared equals z, bk squared equal 1, right? You can put k squared to here, then bc equal to 1. So this is the answer. What we did, we just try to find the answer using the remainder theorem, but it's can't because the divisor is x squared plus k squared, so we can't put anything to cancel the psi x, right? So therefore I am just using long division, right? So long division we simplified it further and we found some remainder. This is not possible, right? Because the remainder should be 0, not the x, this coefficient and the constant coefficient is surely getting 0. So I equal 0 and I made a connection with BC, right? So this is the another kind of situation we haven't discussed yet, right? Okay children, so this example is allocated for you. 4x cubed minus bracket 3p plus 2 x squared minus p squared minus 1 into x plus 3 is divided by x minus b, which is a factor of function, right? You have to find the values of p. Okay, you can try it as a homework. So now I selected another example. Let px equal x cubed plus 2x squared plus 3x minus 1 and qx is x squared plus 3x plus c. Using the remainder theorem, find the remainder when px is divided by x minus 1 and the remainder when qx is divided by x minus 2, right? You have to state the remainder theorems again for these two different cases, right? And also verify the px x minus 1 into qx plus 5. Find the remainder when px is divided by x minus 1, x minus 2. Okay. So I selected these questions from the past paper book. This is 2016 LL paper. Alright. So we need the remainders when So first of all I am just putting px x cubed plus 2x squared plus 3x minus 1. Qx is x squared 3x plus 6, right? So px is divided by x minus 1. Qx is divided by x minus 2, right? Okay, so I am assume psi x and the remainder as r1, psi 2x as the remainder r2. So px equal x minus 1 psi 1x r1, qx equal x minus 2 psi 2x plus r2. So I am going to put x equal 1, then p1 equal r1. Here q2, I am putting x equal 2 as a r2, right? So right now p, we know the function of p. So p means this one, then we can put 1. 1 plus 2 plus 3 minus 1 as r1, then r1 is 5. Here I am just putting x equal 2 to the qx, then 2 square, 3 into 2 plus 6, r2. This is 4, no? 4, 6 is 10, 10, 16, R2 is 16, right. Then verify that px equal x minus 1 qx plus 5. How to do that? Can you see here px over here, px, no, x minus 1 also here, and r1 we found as 5, right? So I am just putting r1 5, right? So px is x minus 1, the x into x minus 1 equal to px, right? So what happened here, can you see, once the psi 1x is like our the psi 1x, if the psi 1x equal to qx, so the qx, then the expected answer will come, right? So what you have to do, you have to show the psi 1x equal to qx. So what is the method of finding psi 1x? Psi 1x. So all the time what we did, we cancelled the psi 1x, no, we avoid the psi 1x. So now the case is, you have to show px equal x minus 1 qx plus 5, right? So this equaling these two, you can see psi 1x equal to qx, psi 1x equal to qx. So you have to show that psi 1 equal to qx. So qx also is given. Then what I am going to do, I am just using long division. X cubed 2x squared plus 3x minus 1, x minus 1. You can put x squared, then x cubed minus x squared, then 3x squared, 3x minus 1, and also I am putting 3x squared minus 3x, and 6x minus 1, and also I am putting 6x minus 6, so this is 5, right? So you can see the remainder also coming with this method, right? But the psi, this is our psi x, no? Then psi x is directly equal to the qx, right? So now the other expectation is coming. Our expectation is like px x minus 1 psi x, now it's like qx x squared qx plus 5. This is our answer, right? So further that, find the remainder when px is divided by x minus 1 and x minus. So you know, if you are dividing something by a quadratic equation, the remainder should be always the first order, right? Right. So what we're gonna do now, again writing px and dividing by x minus 1 and x minus 2. So I think all of you all of you are thinking about that way. But I am using another way because we found this, and also we found px is divided, the qx is divided by x minus 2, which is 16 in psi 2x. So qx equal x minus 2 psi 2x plus 16. This is what we got as the first result, right? So what I am going to do, I am just substituting this qx to over here. And what happening? So I am putting as capital A, capital B, substitute to the capital A. Then px will be x minus 1, qx as x minus 2 psi 2x plus 16 plus 5. Px equal x minus 1, x minus 2 psi 2x plus 16 x minus 1 plus 5, right? So what is this? X minus 1, x minus 2 psi 2x plus 16, right? Can you see? This is our divisor, right? This is our function px. This is our quotient. This whole thing is our remainder. So like px divided by x minus 1, x minus 2, the remainder is psi 2x. The quotient is psi 2x. The remainder is 16 x minus 1 plus 5. So this is our remainder, which is 16x minus 11. Actually, obviously, this method is very useful, right? Because what we did, we substitute qx, right? We substitute qx value to the basic equation. Okay, children, let's move to the repeating application of the remainder theorem. So in this part, we are focusing another special identification. So what is the repeating application of the remainder theorem? Assume if you have a function fx which is divided by x minus c, right? And you will get psi 1x r1. And again I am taking psi 1x. I am going to divide by x minus b. Then psi 2x, and this is r2. Psi 2x is again divided by x minus c, psi 3x, and r3. So what we did, we take the function and divided by x minus a, and the quotient is psi 1x and r1 remainder. And psi 1x is taken and x minus b divided by x minus b, and we get quotient as psi 2x. And again I am putting psi 2x and divided by x minus c. Then what happened? Function of x is divided by x minus a, x minus b, x minus c in a repeating way. Then fx, so we can write the result as fx equal x minus a into psi 1x plus r1, and psi 1x x minus b psi 2x plus r2, psi 2x x minus c psi 3x plus r3. These are the results using remainder theorem. So the only difference is we divided the function repeatedly with x, a, b, c, right? Okay. Then now I am going to simplify it further. So what I am going to do, I am just substituting third equations to the second equation. Then it will be psi 1x x minus b into x minus c psi 3x plus r3 plus r2, and simplify it. X minus c psi 3x x minus b r3 plus r2, my fourth equation. So after that, the fourth equation is substitute to the first equation. then it is fx x minus a, right? The bracket is psi 1x x minus b x minus c psi 3x plus x minus b r3 plus r2 again plus r1, right? I am going to solve the bracket x minus a x minus b x minus c psi 3x x minus a x minus b r3 plus r2 x minus a plus r1, right? So what happened? We found a function x. We found a function x fx like in this. So what is this? So you can see this whole thing is our divisor, right? So this whole thing is our remainder rx. This is our quotient. This is our quotient. So you can interpret your final answer. Fx is minus x minus b minus c by 3x. This is our rx. This whole thing is rx. So what happened? Once you use the repeating application method, the repeating application of the remainder theorem, you have to divide the function one by one and connect all the simultaneous equations together and connect those, and you will directly find the remainder of the whole the product divisor, the remainder of the whole product, right? Whole product. Okay. Right. Okay, under that theorem, I'm going to describe a question. So I'm taking this question from the LL paper 2012. Gx is given, right? The Gx is already defined. So we have to show x plus 1 whole thing square is a factor of Gx using repeating application of the remainder theorem, right? So we have to show Gx is a factor of x plus 1 whole thing square, right? Okay, so using only the repeating application, right? You can't take this and dividing by whole x plus 1 square and the remainder is 0. That is not what they are asking. They are asking Gx is a factor of x plus 1 whole thing square using the remainder theorem repeatedly, right? Okay, so repeatedly means, so you have to divide it by x plus 1 whole thing square. Whole thing square. Right. So whole thing square means I am derive it into x plus 1 and x plus 1. X plus 1 and x plus 1. Okay. Okay. So what to do? So you have to take Gx and should divide it by x plus 1 and you will get psi 1x and some remainder, and psi 1x again take divide by x plus 1 and psi 2x again r. So this r is getting 0 mean this whole process, right? The whole Gx is a factor of x plus 1 whole thing square. So that is what we are expecting in this question, right? So you can see we need psi 1x, no? We need psi 1x. Then I am going to divide. So psi 1x mean we have to method to find the quotient, right? So this is the only method of finding the quotient. X cube, x to the power 4, x cube, right? 3x cube, x square, and I'm going to use 4x square 2x plus 2, and I'm just putting 2, and it's 2x plus 2, and it will be 0. Therefore, the gx is a factor of x plus 1, right? Therefore, x plus 1 is a factor of gx, right? So this is our psi x now, psi 1x now. What I am going to do, I am going to divide psi 1x again by x plus 1. Again divided by x square two x plus 2 0, right? So this is my psi 2x now. So what happening, again the factor will be 0, right? The factor will be 0 means x plus 1 is a factor of x cube plus this one, then the whole gx, right? Before that you have to write psi 1x, so x plus 1 is a factor of gx, psi 1x, right? So therefore x plus 1 whole thing is a factor of gx. This is our final conclusion of this case, right? So gx is x plus 1 whole thing square is a factor of the gx. Okay. And one more part is in this sum, gx is show that gx can be state in x minus a whole thing square, x squared plus bx plus c, right? So what to do about this? Now we found the final property of when gx is divided by x plus 1 whole thing square, right? So this is my final property now. Gx is equal x plus 1 whole thing square into x squared plus 2x plus 2, right? Because gx is x plus 1 whole thing square is a factor of gx, right? So what we need, we have to state gx as x minus a whole thing square, x squared plus bx plus c, right? Now it's okay, ne? A, B, C is like a like minus 1, B like 2, C like 2, right? Right. And also show that for all real number x, gx is greater than or equal 0. So how to do this? For all real number for all real numbers x, right? For all x in real number, we have to show gx is greater than or equal 0. So how to prove this? So you know here gx is equal to x plus 1 whole thing square. Whatever the x value, this whole thing gives the positive answer. So but we don't know anything about this, right? We don't know about this one. So what I am going to do, I am going to computing square this 1, 2 is divided by 1, then x plus 1 whole thing square, and minus 1 plus 2 is plus 1. So what happening? So this is my gx, right? This is my gx, right? Again you can see whatever you put as a x, right? This is also greater than or equal to 1. Once you put minus 1 as a x, then whole thing is 0. Once you put anything to here, then 0 is square or whatever, something is square is positive, added plus 1, so it means it's also greater than 0. Then the whole product is greater than or equal. That's what we are, that's what they expected. All the real numbers, x is greater than or equal 0. Okay, so this is the exam question 2012 LL paper. Right, so I think now you might have a little bit idea about repeating application of the remainder theorem. Okay children, I put some homework questions to be done and you can try it. If you have any doubt, please feel free to ask it. You can ask it from putting message on the comment section or wherever. So thank you very much for being with us, and don't forget to subscribe my YouTube channel via online tutor.